guys, I want to do a video on area and perimeter. Now, for some of you, this may be a little bit of a review, but then I'm gonna kind of remind you what area and perimeter are, and then we'll take it to the level that we're doing in math right now. Now, the reason that I really want to spend time on this is you have to realize you will use area and perimeter problems all the way to high school, all the time, and in real life, all the time. And even the stuff I'm going to come up with right now, just to kind of demonstrate to you what I'm talking about, it's all stuff that I have done in my life, things that I can relate to. And maybe you can't right now, but I'm telling you, in your life, you will use this all the time. And then definitely all the time in math, okay? And you guys know I've taught 8th grade, and I'm telling you this is one of those things that comes up over and over again, all right? So, area and perimeter. For the most part, we're going to be talking about rectangles or squares. So pretend that that is a nicely drawn rectangle. We can tell it's not. Pretend it is. The long side of the rectangle is the length, and they'll use an L. Sometimes like a lowercase l like that. I'm going to keep mine capital so that I don't end up confusing you. Okay? And then the shorter side is the width, and they'll use a W. All right? And then in a square, pretend this is a nice square because we can see it's not. In a square, they may not use length and width. They may, but they might just say side. And think about why they would just say side. Okay, think about it. Hopefully you thought of it. It's because length and width make it sound like it's two different numbers, and with the square, it's the same exact number. So this is a side and this is a side. And because they're all the same length or width, however you want to think of it, we might just call it a side. So if you see that, that's probably an indication that that you're dealing with the square. All right, so let's talk about perimeter first. So when I used to work at a movie theater, we used to do perimeter checks. So what that means is I started in one corner of the movie theater and I walked across all the sides of the building, all the way around the perimeter, and I checked for trash. Not fun. Not fun at all. But eating lots of popcorn was fun, so don't not work at a movie theater just because of my perimeter walk here. Okay, so we had to do a perimeter check, a perimeter walk. And I had to walk the entire outside of the building. And that is what perimeter is. It's this distance plus this distance plus this distance plus this distance. So it's really length plus width plus another length plus another width. And we can write that as 2 lengths plus 2 widths. Okay, and that's what perimeter is. So when we're dealing with perimeter, we are really dealing with addition. Okay, a little bit of multiplication to make our lives easier. We could do 2 instead of adding it twice, because here we'd have to add it twice. So some multiplication, but it's really repeated addition because we're adding all 4 sides. So over here with our square, we would do s plus s plus s plus s. A way to think of it would be 4s. Now they can make this side an x, and we would say 4x. Okay, whatever variable they use to tell you that side length, you're really doing 4 times that number. Okay, and over here, you might see in algebra, so I'm going to put the algebra stuff in pink so that you can see, because you don't really need this right now, I just want to make this connection. In algebra, you might see this is an x, and this is a y. And so when they were when they tell us to calculate perimeter, I don't know what x and y equal, so I can write 2x plus 2y. Okay, and that's the type of problems we do, and that's why perimeter we use in algebra, we use it in geometry, we really use it in life. Okay, so hopefully that makes sense. Let's talk about area. So I'm going to redraw my not so wonderful rectangle. and then we have my square. And we still have length, and we still have width, and here I'm going to make it S, and then we'll talk about if it's an X. Kind of doesn't change anything, but I'll put that example down too. So area. Now, here's what area is. Area is all the stuff on the inside. So think about you have maybe like a kitchen space or a bathroom space, and you're going to tile that. Well, the area will tell you how much tile you need to buy. So let's pretend these are even. Let's pretend that the length of your, whatever it is, bathroom or kitchen, can fit 1, 2, 3, 4, 5 tiles. And let's pretend that the width can only fit, let's just make it 3. Pretend those are even. Okay, so the width can only fit 3. Well, what we do to find the inside is we do length times width, and we know that 5 times 3 is 15 tiles. So I would need to buy 15 tiles to fill this space. And if you want to check that my math makes sense, I extended the problem, and let's count our tiles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so when we talk about area, we say length, oops, if I could spell, that would be great. We say length times width. Okay, now with our square, I really want you to pay attention to this part. With our square, because the length and the width are the same exact number, we can say S times S, but that really means S squared. Squared. Did you hear it? That is the whole reason that we say squared when we're talking about a power of 2. And it's the reason we even call this shape a square. Because when we find the area, we square the number because it's the same side. So let's pretend that the length and width was 3. So our side length was 3. 3 times 3, which is 3 squared, which is 9. Okay, so that's not a coincidence that we use the word squared. And hopefully your brain's already going, ooh, well, how about cubed? How about cubed? Okay, so we'll get there one day, not today. All right, so area is length times width, and in a square, it's that one length or width or side length, however you want to think about it, squared, times itself. Okay, now the reason that we use this in math right now, because, oh my gosh, I'm telling you, we use this all the time in real life, is a problem like this. The area of a rectangular sandbox, is 56 2/3 square feet. Okay, that's the area. Then they tell us the length is 8.5 feet. Okay, so we need to really think about this. We have the answer. We know what the area is. When we know what the length is, what are we missing? We're missing width. Okay, so we're missing the width. But we know length times width equals area. So how do we undo a problem where we know something times something equals it? Well, think about it with just smaller numbers. If 2 times 3 equals 6, let's pretend I didn't have this number right here. So what times 3 equals 6? Well, we know the answer is 2 because it's kind of easy to come up with. But what could you do with the 6 and the 3 to get back to the 2? Divide. So 6 divided by 3 is 2. So we would do 6 divided by 3 and get 2, and then we know what our answer is. So we're going to do the same thing with this, is we're going to start with the answer, the area, and we're going to divide it by the length, and we will have the width. Okay, so I'm going to erase this and then kind of rewrite it as a math problem. Well, not that this isn't a math problem, but we're going to rewrite it with just numbers. Okay, so we have the area is 56 2/3, and we know if we divide the length, which is 8.5, we're going to get the width. Okay? So, step 1 is go. Tell me. Change them into improper fractions. Good job. Okay? So, we are going to change this into an improper fraction. So, 56 times 3. So 18, 15, 168 plus 2 is 170 over 3. And then 8 times 2 is 16, plus 1 is 17 over 2. Okay, so we have turned them both into improper fractions. Now, what do we do next? Look at your notes if you need to. That's right. We turn it into a multiplication problem. I say, that's right, like I can hear you. I'm trusting that you're talking to me here, okay? So we're going to turn this into a multiplication problem and flip the second fraction. Now, oh my gosh, my numbers are huge, and I really don't love that. So don't forget your cross-canceling strategy. 17 goes into 170. So 17 goes into itself once. It goes into 170 10 times. Oh, my numbers just got so much smaller. I'm so happy. So now I'm going to gather up and multiply straight across. So 10 times 2 is 20. 3 times 1 is 3. Okay, so our area is 20 over 3. I think in this case, it would be good to make it an actual decimal. So I'm going to erase just so I have space, and then I'm going to do 20 divided by 3. Because it would be really weird if you went to the store, if you were, let's say, using tile or something, and you're like, oh, could I have 20 over 3 feet of tile? They'd be like, really? You do the math, okay? So let's do the math. So remember, your top number goes under, divided by 3. It's going to be a decimal, so I'm going to give myself a decimal right now. That way I don't forget. So 3 into 20. So 3 times 6 is 18. And then I subtract. I have 2. I give myself a 0. I bring down the 0. 3 into 20 again. Oh, I see a repeated fraction. So about 6.6 repeating. Now, if we're talking tile, okay, and I know the example wasn't necessarily about tile, but I just want to make this clear. If we're talking tile, would we go to the store and say we need 6.6 repeating tiles? No. So would we say we need 6 tiles? No, or else we're going to have a big gap. We're going to have a shortage. This is where you want to round up. We need 7 tiles. And if we have extra, then that's okay. Okay, so I do want you to think about that in these problems. When does it make sense to round up? When does it make sense to round down? When does it make sense to use a decimal? When does it make sense to use a mixed number? Not as often. And in those just kind of computation problems, it's okay to leave it as an improper fraction as long as you always simplify. Okay? If you have any questions, make sure you email me so that I can help you, or maybe send you just a second little video that might clear things up for you. Okay, thanks guys.